Hello, welcome to Zahid's data mining channel once again. My name is Zahid Islam, and today I am going to give a very brief introduction to one of our paper on corrupt record and attribute value detection technique. So here you can see an example toy dataset where we have 15 records up to R15, and there are 3 different variables, and some of the values are actually corrupt, incorrect. So this is what we mean by corrupt record or corrupt value. And then how do you detect them automatically? So this is the paper that deals with that. And this presentation is mainly for research students, research higher degree students, PhD, doctoral, honors, or even coursework data science students, or even some of my colleagues, other researchers can also watch these videos. The main purpose of the videos in my channel is to explain the basic concepts of the paper, so that then when you read the paper, that will make more sense. A preprint version of the paper is also available on my webpage. If you go to the publication link of my webpage and search for this paper, CAIRAD, this is at the moment paper number 80. If there is a preprint available, click on it. It will take you to the ResearchGate, and you can actually download the paper there. Okay. Now let's assume that we have a dataset like this, this left one, and some of the values are corrupt, but we don't know that, right? We don't know that. So the very first step of this paper, of this technique, CAIRAD, is to discretize any numerical values, numerical attributes. So salary is a numerical attribute, and then it, in the first step, discretizes the salary values of the dataset. Now there are various existing discretization techniques, and you can watch them later, watch some of the videos later on. We have a discretization technique as well, and anyway, you can use any existing discretization technique to discretize the values. That's step number 1. Then step number 2 is here to actually compute the coappearance matrix among the values. So a coappearance matrix may look like this. So there are 3 variables here in this dataset. 3 variables: education, position, and salary. So there are 3 variables, and then there are 3 variables. It's a 3 by 3 matrix, and we have all the possible values, domain values of each of the variables. And now we just compute how many times they coappear. So now, after the coappearance matrix, the third step is to identify the noisy values. So that is actually nothing but comparing the coappearance of a value with the expected coappearance of the values. So say, for example, coappearance of value diploma and DIP and L is 0. And of course, that is lower than the expected coappearance of the values. Similarly, coappearance of PhD and position P is 7, which is more than the expected coappearance. So here, the coappearance of PhD and P is more than expected coappearance. But here, the coappearance of PhD and AL is lower than the expected coappearance. Now, if we find in any record that two variable values, attribute values coappear, where they have a overall coappearance in the whole data set lower than the expected coappearance, then we suspect them. So we suspect that either of these 2 values is corrupt, right? And then based on that, we actually impose a suspicion score. Now at this stage, let us assume that we are dealing with record number 8. We will deal with a record at a time. So record by record, from record 1 to 2, then 3, and etc. Let's assume that at this stage we are dealing with record number 8. Now we see the attribute values are PhD and AL, and then we go to the coappearance matrix, and we find that PhD and AL are actually co-appearing less than the expected number of co-appearance. So we impose or we assign some suspicion score or at this stage on both PhD and AL, because we don't know which value is actually corrupt. We understand that it is highly likely that one of these two values is corrupt, but we don't know which one. So we assign some suspicion score on both of them. Now then we check that what is the other values. So the other values is PhD and salary 147, which has been discretized. So salary 140 to 147, and then we go there PhD and salary 140 to 147, and we see that the co-appearance is 7. So that co-appearance is above the expected level of co-appearance. So we don't suspect them. Neither PhD nor salary is suspected in this pairwise comparison. So we do not assign any suspicion score for them. Now, what is the other possible pairs? Other possible pairs is now for record 8 is AL and 140, 147. So let us now check for AL and 140, 147. And then we see that there is also a very low co-appearance. So the co-appearance is less than the expected number of co-appearance. So then we again assign a suspicion score to both AL and 140 to 47, these both values, right? So at the end of that, for the whole record, we find that PhD was assigned a suspicion score once, 140, 147 was also assigned a suspicion score once, but AL was assigned a suspicion score twice. So that indicates that in this record something is wrong and possibly AL is the culprit. So this is possibly the corrupt value. Now this is how it identifies the corrupt values from a data set, and actually for all of the records it tests the same test that I explained right now, and it identifies the values that are likely to be corrupt. The technique was tested very extensively with 96 different noise combinations on 4 different data sets. One of them was adult, and the results have been presented here. So if you actually now read the paper, you will see, you will understand the technique more clearly, and you can also see the experimental results. Here we have a summary of the experimental result in terms of 3 different evaluation criteria, and the technique was compared with 2 other existing techniques on 4 different data sets, and as you can see, it gives really significantly better result in terms of corrupt value and corrupt record detection. As always, thanks for watching.